Alright, boys and girls, let's go ahead and get started on lesson 7.7. Just so you're aware, it's 11 o'clock on a Saturday night and I am sleepy, so hopefully I won't make any silly mistakes, but forgive me if I do. 7.7, I think you'll enjoy this lesson. It's not too difficult. We're going to be combining like terms, and our objective is I can use the bar model to show how to combine like terms. We have used the bar model before when we were doing fractions, and a couple other things, so hopefully it will look a little bit familiar and you will find this lesson fairly easy. So first of all, we need to discuss what is a like term. Like terms are terms within an expression that have the same variables with the same exponents. Numerical terms or number terms are also like terms. I'm going to show you a chart. Here it is. Hopefully that will make a little bit more sense. I would probably copy this down in your notebook. Maybe not all three examples. You definitely could, but you don't have to. But let me explain this chart to you. So we have our algebraic expressions here. Oh, where's my laser pointer here? There we go. We have our algebraic expressions on this column. If our expression is 5x plus 3y minus 2x, okay? Last week we talked about terms. Now, the terms in this expression are 5x, 3y, and 2x. So we have 5x there, 3y there, and 2x there. Now, when we're talking about like terms or similar or common, things that are the same, like terms, it is the terms with the same variable. So 5x and 2x have the same variable. 3y, that y is different than the x's, so it is not the same. So our like terms are 5x and 2x. And the second example, it also said, it said that it's essential for it to have the same exponent. So here we look at this algebraic expression. We have 8x squared plus 4z plus 12x squared. I want you to think about it. What are my like terms going to be? Here's my terms, 8x squared, 4z, and 12x squared. Which ones are alike or similar? Hopefully you recognize that 8x squared and 12x squared are like terms. Now, what is important to know that if this would have been 4x, it would still not have been a like term because these are x squared. So you can only combine those squareds with other squareds, or if it's 8x cubed, it could only be combined with another x cubed. Last example is 15 minus 3x plus 5. Our terms are 15, 3x, and 5. You notice we only have one variable and it's our 3x. So it's like, oh, Mrs. Twisdale, there's not anything that I can combine. Well, there is. In the definition on the previous slide, it said that the numerical terms or number terms are like terms. So 15 and 5, those are like terms because they are numerical or number terms. So those can be combined when we're talking combining like terms. Okay, here's our first example. Example 1 is baseball caps cost $9, and patches, which would go on the cap, cost $4, and shipping costs $8 per order. The expression 9n plus 4n plus 8 gives the cost in dollars of buying caps with patches for n players. So if we had a certain number of players playing and they each got their own cap and their own patch plus an order for shipping, we would have 9n plus 4n plus 8. So this is what it's asking us to do. We're going to simplify the expression 9n plus 4n plus 8 by combining like terms. So let's take a look at that expression. I'm going to just rewrite it here. Use yellow. Whoa, not with that one. Hold on. Let me switch. 9n plus 4n plus 8. And hopefully you're noticing that these are our three terms. Now, if we have two terms here that are alike, you'll notice that it's 9n and 4n. 8 is a numerical term. It cannot be combined. But we can combine these two terms. Now, our n will stay the same. Our variable stays the same, and our coefficients because of our sign here is an addition, we're going to add our two coefficients together. 9 plus 4 is 13n. And then we'll say plus 8. Now I'm going to draw it in a bar model for you just so you can see an example. So if I have 9n, 1, 2, 3, 4, 5, 6, 7, 8, 9, and these are all, if I could draw little tiny ends in there. It's kind of hard on an iPad. I'm sure you could do it in your notes just fine. There's 9n. And we also have, let me switch colors, we have 4 more n, plus 1, 2, 3, 4. These are also n. Because they're all n, we can combine them. Oops, that was a weird one. And we have 13n. Because 8 is not a variable with an n, or a coefficient with an n variable, we can't combine it. It has to stay on the outside. So we can just go ahead and write 13n plus 8. And this is our simplified expression. We cannot solve it because we don't know what n is, but we do have a more simplified expression. So when we find out what n is, we could just plug it in. Okay, so let's look at this example. Here we have a paintbrush scenario. Paintbrushes normally cost $5 each, but they're on sale for $1 off. On sale automatically tells my brain subtraction, because if it's on sale, it's going to be less. A paintbrush case costs $12, so a case to hold my paintbrushes is going to be 12 bucks. The expression, here we have 5p, which is how much it started at, minus p, because they're $1 off, plus 12 for the case, is used to represent the cost in dollars for buying the paintbrushes, plus the case. We're going to simplify the expression by combining like terms. So here again I have 5p minus p plus 12. How can I simplify this? Which terms are like or similar? Hopefully you're starting to notice, well, Mrs. Twisdale, 5p and p are alike. I could combine those and make this more simple. Let's draw it out. Here's 1, 2, 3, 4, 5p. I'll draw a little p in there. There we go. And if I subtract one of those, it leaves me with how many here? Hopefully that subtraction is not too difficult for you, and you'll notice that there are 4p left over. So, to combine these terms, 5p minus p plus 12 can be simplified to 4p, and then I cannot forget to include my plus 12. And that's my simplified expression. Remember to ask questions if you need help with these. I feel like they're pretty simple and straightforward, but remember, you can always pause, rewind, raise your hand, ask me questions. That would be great too. Okay, here's a try it problem for you. The first try it problem of today. There's a radio show. It lasts for 8 hours. And for every 60 minutes of airtime during the show, there's 8 minutes of commercials. Simplify the expression 60h minus 8h. Go ahead and pause the video and try it. See if you can make that expression more simple by combining the like terms. Okay, hopefully you went ahead and tried that problem. I'm not going to draw a bar model because it's going to take me way too long to draw all these to draw 60h boxes. But if I have 60h minus 8h, I can combine those because they have the same variable. Now, you might want to say, okay, well, let's do 60 times 8, or let's do 60 plus 8. But I'm here to tell you that we need to subtract our coefficients because of the sign in the middle. So 60h minus 8h is going to be 52h. And this is a simplified expression. They mean the same thing. They're equal to each other. 52h is the same as 60h minus 8h. Just an easier, simplified way to write it. Okay, here's another example for you to try. I'll go ahead and read it and then you can pause it and try it out. For each gym class, Cottonwood High School has 10 soccer balls and 6 volleyballs. All of the classes share 15 basketballs. The expression shows how many balls there are for C classes. Simplify the expression 10C minus 6C plus 15. Go ahead and try it by yourself and then play the video to see how you did. Okay, let's go ahead and see how you did here. Our terms, 10C, 6C, and 15, we have two that are alike, 10C and 6C. We can combine those, and we're going to combine them with subtraction. 10C minus 6C. Let's see. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10C. Now if I subtract 1, 2, 3, 4, 5, 6, cross all those off, it leaves me with how many left over? This was subtract 6C equals 1, 2, 3, 4C remaining. So here I have 4C was my combined like term answer, but that's not the answer completely by itself because I need to include my other term, which was 15. Don't forget to include all of the terms. If you combined them, awesome, but if you didn't, it still needs to be a part of the expression because it's important to point out how many basketballs they have. So, hopefully you got that one right. Last example for you to try on your own, and I just want to put in a little plug for your appetizers. The reteach appetizers are actually going to be a little bit trickier on this. I would recommend highly looking at the Sharon shows. I would look there, and also your homework. I may or may not have done a couple of the problems from your homework. So if you want that extra credit, this would be a great lesson to do the extra credit on. Okay, so a public library wants to place 4 magazines and 9 books on each display shelf. Simplify the expression that shows the total number of items on S shelves, 4S plus 9S. So if we have our display shelf, we have 4S, 1, 2, 3, 4, plus 9S, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we have how many S? 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. 13 S. And you'll notice that this is my completed variable because I combined all of my terms. I didn't have anything else that I couldn't combine. So there is only one term here because I combined both other terms. Alright guys, that's the end of this lesson. It is a shorter one, but feel free to go back, rewind, ask questions, make sure you do your appetizers. This is an awesome lesson to practice your skills on. Thanks so much.